This tutorial will illustrate the communication between your variable frequency drive, which I'll refer to as VFD, and the machine control board. So let's simplify so that only our VFD display overlays a simplified schematic diagram. Now before we begin, please ensure the spindle lockout switch is set to run, an optional power drawbar is not engaged, and the spindle door is properly latched. These switches bring 115 volts AC to the machine control board spindle control circuit. To start the spindle in PathPilot, set the RPM to 1000 and click forward. The machine control board energizes the C2 contactor, which powers the VFD. The machine control board commands the spindle to rotate forward at 1000 RPM. Highlighted are the communication wires of a functional machine that makes this motion happen, consisting of ready. The VFD is standing by to accept spindle instructions from the machine control board. Run. This signal initiates the spindle rotation. Speed. This is the RPM instruction. Forward reverse. When applied, the signal rotates the spindle in the forward direction. When the signal is removed, the spindle reverses. Common. This provides a return path for the signals between the machine control board and the VFD. Our diagnostics guide you to measure voltages or make jumpers to isolate potential issues in these circuits. Let's look at the logic signals individually. With contactor C2 latched, the VFD is powered. Terminal B2 provides a 24-volt DC ready signal which is routed to the machine control board via a wire labeled J14. The VFD readout shows RD 0.0. RD means ready. You will see this condition when the spindle stops at the end of an operation, unless contactor C2 is unlatched, such as after a tool change where the spindle door or optional power drawbar disrupts the latching circuit. The machine control board generates the speed command, a variable signal between 0 and 5 volts DC depending on the spindle speed you desire. Your machine control board has two related indicators, great for diagnostic purposes. A green LED that flashes proportionally to the speed under PathPilot control, and an amber LED whose intensity varies with speed under either manual or PathPilot control. The machine control board then sends 24 volts DC signal back to the VFD through the closed contacts of relay K2, connected to J13 and J14 as a run command. This signal initiates the spindle rotation, if no other signals were applied yet, in reverse. A similar circuit on the machine control board sends 24 volts DC back to the VFD through the closed contacts of relay K4 connected to J15 and J16 as the forward reverse signal. When present, the spindle drives forward. When absent, the spindle reverses. The VFD display will include a minus symbol with the frequency and speed when spindle reverse is desired. Our diagnostic processes walk you through observing the VFD display for these conditions and instructs you on procedures to resolve issues that you may encounter. As a final review, I'll remove the signals and show the VFD displays you would encounter during troubleshooting. Removing forward reverse, the spindle rotates in reverse regardless of the setting in PathPilot. Removing speed, the VFD indicates FR 0.0. Removing common is equivalent to removing speed. Removing run puts the VFD to ready. Opening the spindle door to change a tool unlatches the C2 contactor. The VFD display will show an undervoltage trip condition such as TRUV just before the capacitor within the VFD discharges.